Hello, everyone. Thank you for joining today's AWS user group study series. My name is Christiana, and I'll be your moderator for today's session. And today being the fifth episode of the AWS study series, we are going to be delving into the world of building chatbots and secure chatbots using artificial intelligence and machine learning. For the benefit of those that are just joining for the very first time, please make use of the comment sections for your questions and also for the purpose of networking. Can you tell us your name, introduce yourself, and where you're joining from in the comment section? Like I said, my name is Christiana Olusegun, and I'm joining from Lagos, Nigeria. So let us know where you're joining from. And you can also tell us your expectations for today's session, because it's, for me, I know that it promises to be impactful and, very insightful. Let us know where you're joining from. Okay, so while we are doing that, our topic today is going to be a spicy one. It is building a secure document chatbot using self-hosted Ollama³ and RAG technology on AWS EC2. I know that sounds like a lot, right? But don't worry. Our speaker here, we have two, not one. We have two speakers who will be taking us through this journey. So you might be wondering, what is Ollama³, what is AWS EC2, or what are RAG technologies? They are here to take us through all of this and break all these technical concepts into simpler forms for us. And our guide in today's session is none other than Felix and Daniel. They are going to take us into this topic. So Frank-Felix is a machine learning, or we say artificial intelligence engineer and solutions architect, with focus on designing and building data and AI intense systems. He's proud to be part of the AWS Community Builders Machine Learning Program with about 5 certifications in AWS. He has a strong foundation in cloud technologies and eager to contribute to the AWS community. He's passionate about sharing knowledge. Felix loves contributing to the community and helping others grow in data science, machine learning, artificial intelligence, and generative AI on AWS through talks, session, and workshops. Wow, that's interesting. And for Daniel Akhabue, he's also an AI/machine learning engineer and cloud solution architect with hands-on experience in building AI-driven solutions across diverse domains, including generative AI, machine learning, and data science. He has led and contributed to impactful projects across a range of industries such as edutech, assistive technology, health tech, fintech, and supply chain technology, consistently delivering solutions that address real-world challenges. As a community champion at Data Scientist Network, DSN, Daniel has won multiple data science and AI hackathons and has led AI community in Nigeria, driving innovation and knowledge sharing. He's also a technical writer, sharing insights and expertise through articles published on leading online platforms in data science and AI space. Wow. From this bio, you can already tell that they know their onions. And We can't wait to hear from the knowledge bombs that you're about to drop for us. So for everyone, I will encourage you to please sit tight and pay keen attention to our speakers today, because at the end of this session, we're going to be having quizzes and brain cracking questions that you get to answer, with the most correct and fast and efficient person to answer the question get to have some AWS goodies. I won't tell you what those goodies are. So stay tuned, share this link with your friends that are also cloud enthusiasts so that they can benefit from what we have for us today. Thank you very much. Who is going first, Felix or Daniel?
Hi, Christiana. Can you hear
Either
me?
way. Yes, I can hear you. Thank you.
All right, so I'll go first. Good evening, everybody, or good day, good morning, depending on where you're watching us from. It's nice to be back. Right, so I will share my screen briefly so that we can jump right into the topic for today. Right, Daniel, confirm if you can see my screen. Hi, Daniel, are you there? Can you speak? Um, okay, I guess I can see my screen from the the screen here, so I'll just go ahead. So again, good evening, everybody. Today we are going to be talking about a very interesting topic: building a secure document chatbot using self-hosted Ollama³ and RAG technology on AWS EC2. I know these topics look quite complex. It looks quite techy. It looks very, very AI, very, very machine learning, right? But trust me, it's something that everybody can follow through. In fact, I would say everybody here already understands some of these concepts, but not just in the context of what we are talking about today. So our job here today is to bring you into this context, and we'll all learn together. Right. Okay. Right. So if you're familiar with some of the sessions, if you are in the other session we took where we spoke about building generative AI for generating quiz and assessing quiz, yeah, there was a story time. So we're back to story time. Like, we like to tell stories because that way everybody can relate, and it's really, really interesting that can follow along. So yeah, meet my friend Bola. Right. So Bola is an AI and machine learning engineer, just like myself and Daniel, and she's a, in quotes, fictitious friend, but let's just say she's our friend, right? She works for the government, particularly the Lagos state government, and it's a very, very, very important role, right? Why? Because the Lagos state government is trying to bring in tech, right? Trying to leverage tech to see how we can optimize business or optimize government, right? So she's tasked to create a document chatbot that helps various service areas within the government, and there are a lot of different solutions that could work. A good use case for Bola, when the idea was pitched to her, you say, hey, Lagos State has a lot of standard documents, or Lagos State has a lot of policy documents, and some of these policy documents are internal, right? And we want a solution that we are able to talk to the document like it's an AI chatbot, right? So we have documents, policy documents that are 1,000 pages big, 1,000 pages long, and it's quite difficult for us to go through each document page by page to find out each and every find out information in each different parts of the document, right? The original solution that this organization had was they hired experts for the different parts of the document. So the policy documents could contain policies as regards child rights. You could have some parts of it talking about sports in Lagos State. You could have some part of it talking about technology. So what they did earlier on was to hire experts in different fields, and those experts focus on those little parts of the document, and that way they were able to get efficiency. But here's the thing, Bola knows that she can make the process much more effective, right? So what she's going to do is to build a solution that is able to retrieve relevant information from this particular document concerning any question anybody may ask regarding policies, and the solution should be able to answer back with some answer that is relevant, right? She knows she's excellent at her job, and she wants to design a system that is able to solve this problem. So let's see how the solution would be architected. So if you follow through the story, right, there are three key things that stand out from this story, right? Or let's say four. One thing is Bola knows she wants to build something that is going to optimize business and optimize processes, or rather, in this case, optimize government processes. Right? She's really excited about it, but she need to do three things. She knows that for her to solve this problem and for the chatbot to be able to answer any question at all, it needs to be able to generate responses for anybody asking. She knows she's going to need an LLM, right? So a large language model. So if you have a following the study series, we already know what large language models are. Um, but just to recap, if you have not been following the series, what's the large language model? A large language model is an AI model that has so much information that it can answer just anything, right? It can just answer just any question, right? But I'll point out some problems with that LLMs when we start talking about RAG more in depthly, right? So the second thing Bola needs to do is to find a system that is able to go into any document and is able to retrieve information from just anywhere within that document that is relevant to a question that is being asked, right? So two things. And the third thing she needs to do is because some of these policy documents are are most likely internal documents or documents that should not go out to the public, right? She needs to build a secure system that is able to tie all of these things together. So that means she needs to find how to build a retrieval system. She needs to find how to integrate it with a system that does some sort of generation of answers, and she already know an LLM will help her with that. And she needs to build it very, very securely. So these three decisions is what Bola is taking to the table when she wants to design the system that she's talking about. Fortunately for Bola, she learned a concept recently in AI. It's called RAG, right? Retrieval Augmented Generation. So if for us to understand RAG and why we need RAG, we would just take a step back to just understand a very simple concept, right? So we already know what LLMs are. We have established that LLMs are models, AI models that have so much information. In fact, they have learned almost everything on the internet, and they are able to answer you questions. So AI models have learned so much information and they can answer just about any questions. But LLMs are like that smart, overconfident kid that doesn't know how to deal with information that he doesn't have, right? So we all know that smart guy that doesn't like to not know the answers. So if you ask him a question, he will most likely just want to give you an answer or something close enough to the answer. So that's where problems with LLMs start to come in. LLMs tend to hallucinate. What does it mean to hallucinate? An LLM, when you ask it a question, example, if you have used ChatGPT before, I should not even be asking the question whether you have used ChatGPT before, because I know all of us must have used AI, ChatGPT, Anthropic's Claude, and all of those different beautiful technologies over time. Right. So the problem with them is that on their own, they can hallucinate. Right. When you ask them a question and they don't know the answer, it's pretty difficult sometimes for them to tell you I don't know. They find something that is closest to the answer or looks like the answer, and they try to make up something sometimes and give you the answer. But that won't work for Bola's case. Why? Because she's building a standard document for government. So if there is a problem in the mix, if it somehow the AI system responds with an incorrect answer, then there is a big problem. To solve that problem, Bola knows that she needs to augment the responses generated by AI with some information that she knows is correct, that she has somehow retrieved from a document. This whole scenario describes what you call retrieval augmented generation. LLMs on their own can handle generation, but we need to attach a system to them that is able to augment the responses of LLMs with context that is retrieved from a document or a knowledge store. Okay, so there are two parts to RAG. There is the retrieval part and the generation part. We're all familiar with generation. LLMs, generative AI can generate content. It knows that's its job. It just knows with pre-existing information it's being trained with. It just knows how to generate. Right? It's really good at that. Right. But there is another part of RAG which is retrieval, which we need to talk about. Right. There's a whole theory that supports how retrieval works. So the easiest form of RAG is what you call naive RAG, right? So I'd like us to go through some of these concepts before we then go into the practicals of seeing how this work, right? So Bola needs to implement what we call naive RAG, right? A simple system where somebody asks a question like, "Who is Bola Ahmed Tinubu?" Right? And let's say LLMs don't have the answer, or simply, "Who is Felix Frank-Felix?" My information is not too much on the internet, so it's your traditional LLMs would not be able to answer accurately. It might tell you Frank-Felix is a footballer, but that's not true. Although I know how to play a little ball. Yeah. If I went pro, maybe I'll be as good as, let's say, a Messi. But anyways, just to go past that, right? So we want it to be able to answer questions accurately. So what we will do is to build a system where LLMs can go through little bits of information, which we will call chunks, right? If there is a way LLMs can go through little bits of information, right? Imagine tearing down my documents into small parts, example, paragraphs, right? If I have a store that can store little parts of my documents that hold some form of information, if I tear my document into little parts of it, as what we'll call chunks, LLMs can easily read through all the chunks, right? Not read through. We can build a system that can easily go through all the chunks and say, hey, I've seen about three different chunks or three different parts of this document that resembles what you are trying to ask about. So let's say we have a document talking about different people, right? And Frank-Felix is just a small paragraph within that document. So imagine if I've separated all these people's information in little chunks instead of the whole thing, right? And LLMs can find a way to find a similarity between one chunk and the question that is being asked. Then it takes that information in that chunk, adds it to, passes it with the query together, and sends it to an LLM to finally generate an answer. So in doing this, RAG then knows how to answer questions accurately, right? So like I said, there are two major parts to LLMs, retrieval and generation, right? Okay, just to move past this part very quickly. So there's a technology that actually supports retrieval, right? So mind you, all of these things happening under the hood for LLMs and RAG, it's all simple maths, right? It's all simple maths, right? Do you know that it's every single information you have, there is a mathematics that supports the relationship between every single information that is put out there. So for computers to understand um, words and for computers to understand the meaning attached to words, what it does is a mathematical relationship between those words. Example, if you have a word king, right, the mathematical opposite of it, or the opposite of that word will most probably be queen, right? And there's a way to kind of like represent the difference between king and queen, just like you can say the number one and the number minus one, right? So you can assign numbers to those words to be able to somehow connotate the meaning of those words. The whole process of turning words or a sequence of words, example, a sentence, to the mathematical representation of what that word or sentence would be is what you call encoding. Right? So if I can take different small parts of my document and turn it into the mathematical representation of what that word would mean, right? I can then store those that set of numbers that define those sentences. In this context, we call them vectors, and those vectors can be stored somewhere so that LLM retrieval systems are able to quickly scan through them and find the most similar sentences or the most similar context to the question I've asked. This whole process defines or explains what retrieval is, right? So like you see, there are three parts to it. There's query encoding and you go to retrieval. So query encoding is the process of taking any word or the questions that have been asked and converting it to a mathematical representation of that particular word. Then you can then compare that word or the sequence of words that you have, right, to all of the words within your context store. In this case, to hold the value of all these chunks that we are seeing in a document, so we already know something like S3 can hold a PDF, right? But this PDF, we have split it into small, small parts, and we have turned it into a mathematical representation called a vector. Then S3 can hold this document, this store again. We need to put it in a type of store called a vector database, right? So a vector database is a database that primarily hold vectors, right? And this is really, really important, right? So we'll go on to generation. So after the retrieval has happened, somebody sends a query, you go to the vector store to get the most similar context to this query. You can then merge these two together. That's the question and the most probable answers. And you send it to the LLM, and the LLM is then able to then generate an answer. Remember, most likely when we send the most probable context or the most probable answer to the LLM, it automatically has the answer. Example, if you ask who is Frank-Felix from a document where Frank-Felix is, so let's say the document says Frank-Felix is a machine learning engineer. If you send that question, most likely when it is retrieving these answers, it will most likely retrieve that chunk as part of the most probable answers. And now the LLM now has the answer. So LLMs are then able to generate accurate content. Right. So this system that Bola is going to create, all right, this is what the flow would look like. That's what I just described. Right. So the user, when you send a question, that's what the user query would be. The user query is then turned into a vector representation of what the question, what the meaning of that particular question most likely is, or what the meaning is. And this chunk, all these chunks are stored within a vector store. Right. For the retrieval process, when the question is asked, the question chunk is compared to all the other chunks within the vector database, and we're able to retrieve context, which we then pass along with the query to an LLM that is going to spill out an answer. So in this case, this is quite simple. But we have another problem. We have dealt with two things in our design set. We said Bola needs to learn how to do retrieval or need to implement what does retrieval. Bola needs to learn how to do or implement something that does generation. But we have not talked about security. Right. So the third part is Bola knows that there are services that helps her do this the RAG system we're trying to build, right? So, but there's a big problem with it. The problem is that for most of the implementation she has seen, the vector store is usually on running on another server, right? And from the application where she's making the query, or the application that processes the query, has to make an API call to an application over the internet just to fetch queries, right? Again, she also knows that she needs an LLM for generation. Most of the implementation she has seen is the LLM is sitting on another server, and you are making an API call again to another server over the internet for you to be able to get those information. But the problem is she was told that the documents she's using are internal documents and should not go public, right? And obviously, passing it through the internet is making it public. So that means she needs to build an LLM RAG system that runs locally, which means that the vector store and the LLM all run within the same server. Right. Fortunately for her, she found the technology to help her with it. It's called Ollama. So Ollama is a framework that helps us install and load LLMs directly onto your local machine. Right. So Ollama is a very, very great tool or framework that helps us take LLMs, open source LLMs, by the way, that have already been trained or pre-trained models, and you are able to load them onto a server and run it like it's what you are using, example, your chat GPT. Right. So she needs to use Ollama. And for a vector store, she chose to use ChromaDB. And for an embedding model, the model that transformed sentences into numbers, then she chose to use a nomic embed text. And this nomic embed text also runs within or is available within Ollama. So she's going to load both the LLM she's using, in this case, she's using Llama 3.2, which is an LLM for Meta. And she's also going to load the Nomic embed text embedding model, so that she's able to embed the queries and then do retrieval, then go ahead to do generation all from the same server. Right. Okay. So now this is Bola's simple architecture for the POC. Right. So she told the organization, she told government that, hey, let us implement something small. Right. I'm going to build something small for you, small prototype to show you how this system would work. And then we will then see how to integrate this with all of our other systems. So Bola has built a very, very simple system that all of these features will run within an EC2, right? So the simple architecture is she has all of this, all of the RAG and all of the vector database and the LLM runs within an EC2, and the user is able to make a query with a small mobile, small application she has built, small web application she has built, and it's able to respond within the same web application. So right about now, I will just hand over to Daniel so that we can see the implementation of RAG using Python. So thank you very much. Daniel, are you there? Nah, I can't hear you. Hi Daniel, I can't hear you if you can hear me. Let me see. I hope it's not my speaker. I don't think it's my speaker. Someone said storyteller on the chat. Yeah. So yes, I feel storytelling is one of the best ways to cut across any um send across any message, and I hope everybody followed the story. So I guess Daniel is having network issues. Um, I can hear an echo. Hi Daniel, can you hear me? Yeah, I can hear myself your stream, but I can't hear you.
Okay. Hello, can you hear me? Okay, you can hear me. All right, all right, all right, all right. Thank you. Thank God. I've been battling with my microphone since this call started. I'm glad you can hear me now. All right, so let me go ahead to share my screen. And okay, all right. Please, if you can see my notebook, let me know that you've seen it on the chat. Because I'll just quickly swipe back so I can see that you've seen it. All right, all right. Okay, okay, thank you. So we've seen how Bola, through Frank, of course, has actually explained to us the various processes in implementing a local RAG application. I call it local because every resource, every tool you'll be using will be run on your own server. All right. And I think something that Frank would also have mentioned is that we know how these models are very, very large. Most of us can't even spin up any Llama model on our local, desktop. That's our computers, and that's where Ollama comes in. Ollama helps you abstract a lot of the technical processes you need to undergo to spin up your own large language model. I mean, again, it's open source model, right? So coming instead of downloading your weights, downloading every single parameters for this large language model onto your laptop, Ollama helps you abstract that process. Such that you just need to pip install. I mean, for us using Python, right? You just need to pip install Ollama, and then you're able to, get the models that you want to use for your AI application. All right, and so let's go ahead into the processes that we have to undergo when building our own. Let's build our own application like the way Bola has built, right? So we are following Bola's teachings, right? So I had a chat with Bola last night, and that's where she was able to download the stuff to myself and Frank, and she was able to take me through a lot of the technical bits and pieces in implementing our own solution, right? And for me, I think I really want to take this solution and take it to, where I work to see how I can, say, oh, I can spin up my own large language model, on my own server without having to connect to OpenAI or connect to Gemini or connect to cloud. I can do everything I want to do right now on my laptop, and I will not be sweating because my system, has run out of memory. All right. So I know some of the classes we've been taking in this study series, we've been using Python, so I would have to brush through that part quickly. We know that for us to implement any solution in Python, you need libraries for some of them. And we have libraries that are pre-installed in your Python environment, and we have those that you have to install via pip, right? And again, Bola was able to tell me that instead of you trying to, de-abstract some processes, why don't you use LangChain? All right, why don't you use LangChain? And LangChain helps you, scale through some hard stuffs that you need to do, and you just need to just import LangChain or install and import LangChain and its necessary dependencies, and you are good to go. All right. For our application, what I was able to say that you need to, like Great Frank has explained, you're asking a question on a particular topic. That question has to be embedded, which means that you need an embedder, but in more technical, form, an embedding model. Now, embedding model is a model that helps you convert that text to numbers, right? And so instead of us to also download our embedding model from, let's say, Hugging Face and try to spin it up ourselves, LangChain also helps us abstract that process. So, in fact, there are several levels of abstractions because Ollama itself has its own embedding model. So as long as I've pimp installed Ollama, I have access to the embedding model, and I have access to Ollama via LangChain. So you see the various level of abstractions just to make the work easy and sweet. All right. And in building an application like this, you first of all need to have access to the documents and have access to the content in that document. And that's where we need a document loader. And LangChain helps us. LangChain has a resource, or I'll call a library that helps us access our document within our notebook. And then next is the Ollama embedding, also accessed via LangChain. What the Ollama embedding does is, like I've explained earlier, is that it's a model that helps us convert. You see that text that is in your document. It helps us convert that text to embeddings or vectors, like Frank has said. All right. And then the next step is, after we've done all this, we need to, before embeddings, we need to split our text. We need to chunk it, right? Frank has explained to us what chunking is. Chunking is an easier way. In fact, it's the best way for your large language model to access relevant information in your document. And the reason why we need to chunk is because, I mean, the question you can ask is, why don't I just, ChatGPT or any other model, I can just copy the content of that document and put it in ChatGPT and ask it questions directly. But just imagine you have like a 1,000 page document. ChatGPT, will tell you, oh, that you have run out of space, or your token, you've hit your token limit. And so that is why the RAG application is very, very important for specific use cases, because you could have just said, oh, let's just spin up the model in my local environment and just, put document inside, but you have like 1,000 page documents, right? And we know how this technical document can be, and that's why we need to chunk. So chunking just breaks down your documents into several layers that when you are trying to access an answer to that question, you're trying to compare, like Frank said, compare the question vectors embedding to what is inside your vector database. It just selects the most likely chunks or layers that would answer that question. So that's why we need a text splitter, right? And LangChain also helps us, gives us access to that. Then we need a vector database. There are various vector database out there. But for this particular process, I've chosen to use Chroma. There's Pinecone, there are others, right? And then as usual, so LangChain helps us abstract the just helps us abstract our prompts. so that when I'm trying to query my large language model, I just need to call a prompt template. So it already gives me how my prompt should be, and how I should query the large language model. And then we have the output parser, then chat Ollama. That's the way I can chat with the model. And then, yeah, so let's go ahead, right? So the next step, the very, very first step, after you've actually imported your necessary libraries and dependencies, the first step is to load your PDF, right? I mean, let me just put a disclaimer there. It doesn't just have to be PDF. It can be a document. So as long as you can be able to load it in your environment and extract the details from it, it's good to go. And then, like I explained earlier, once you've gotten your documents, you need to split it into chunks. And that's where we have what you call your chunk size and your chunk overlap. Now, I'm just going to explain these two parameters for those of us that will go immediately to implement this particular solution. When choosing your chunk size and chunk overlap, you need to have an idea of how your document is. Now, the chunk size is basically, how many characters do I want to add together? So it means that my first chunk one has 1,000 characters, chunk two has 1,000 characters. Now, when we now go to chunk overlap is saying that instead of just chunking it like that, and you are now querying the vector database to give you the most likely chunks, there are possibilities where chunk one has the answer, but it doesn't have the complete answer. All right. So the complete answer in chunk one is inside of chunk two. So that's why you put an overlap. An overlap says that when you are extracting the chunk from the vector database to give an answer back to the user, let's take chunk two, for example. So what chunk two does is it does -1 plus minus 200 plus 200. So minus 200 or plus 200 upwards, then plus 200 downwards rather. So it says that from chunk two takes 200 characters out of chunk one. That's the ending characters in chunk one, takes 200, add it to itself, then take 200 before chunk three. So that at least it's able to get context before the answer and context after the answer. All right. So that's what we call chunking strategy. And it varies. So that's why it's also an empirical process, because you have to test and check and experiment to see the chunking strategy that works for you. So I'm saying this because you might just use small documents and you don't have to use a chunk size of 1,000. Maybe your chunk size can be like 50 and your chunk overlap can be like 10. Right, so you see why you have to carefully choose your chunk strategy. Now, immediately I've chunked my document, I need to then take those chunks and embed them and push them to what you call a vector database. These embeddings themselves are called vectors. So I need to take them, like Frank has said, for a RAG application, you need a special database, which you call a vector database. So vector Chroma is a very, very good vector database. Like I said, there's Pinecone and there are others. And interestingly, through Chroma, we can then add our chunk and then also embed our chunks, then push it to the Chroma database. So the script I've been able to highlight here just shows how I'm instantiating my Chroma database. The document takes in the chunks, then I'm also declaring my embedding. My embedding in this case is my Ollama embedding. And you remember that I had to import my Ollama embedding from LangChain Ollama. All right. And then I can just name my vector database like funny local rag. Just running this particular cell, create your vector database with the embeddings populated already into the vector DB. So this is very sweet, very simple, very, very easy. All right. And then, of course, then we now go to the LLM and retrieval. We've created the vector DB that has the chunks already. The next thing is we need to also set up our LLM. We've not done that already. And I've chosen that. Well, of all the open source models that are there presently, Llama 3.2 will most likely fit into my needs. Now, depending on your needs, you don't have to provision a bigger LLM. You can use a smaller one that can just serve small tasks. All right. And then I choose the model I want to use, and then I instantiate that model with Chat Ollama. It's Chat Ollama because what I'm doing with it is I'm basically chatting with, so it's not a, it's not just for generating, content or generating, words. It's specifically good for a chat system where you are interacting like a, interacting with a chatbot, like great ChatGPT is technically. So I just need to instantiate it using my chat Ollama. Again, we've brought our chat Ollama from, LangChain. So you see that I don't have to do so much. And then I remember I mentioned prompt templates. Uh, LangChain uses prompt templates. I mean, LangChain themselves created a prompt template to be able to abstract the way you connect to an LLM. If you check out different API endpoints, you find out that each of these large language models have um, different ways to which you can connect to the API endpoint. For what I mean API endpoint, I mean, I want to use ChatGPT, or let's say GPT-4 API. There's a specific way I have to declare the prompt. There's a specific way I have to declare, the user query. If I'm using Gemini, there's a specific way. So what LangChain does is just abstracts it. So any model you are using, you just need to use the prompt templates, and it covers it already. And I'm, declaring my system prompts to which the question will be written inside, and then I'm setting up my retriever. Now it's important what the retriever does in this case is it's what's once I've gotten my query prompt, all right, I also need to embed that query prompt to get the vector embeddings of the query, because I need to compare the vector embeddings of the query to what is inside the vector DB. Now, is once I've done that, it now uses it to retrieve information or retrieve chunks from the vector DB. All right. And so I've done that. And then LangChain also helps you create a chain. A chain in this case is, chaining your prompt to your system prompt to, let's say, your query, and then to the results from your vector DB. You can do this manually, of course, but then LangChain just gives you that template for you to do that. And then I'm creating a function that just chats, with I want to chat with my PDF now. I've done everything. Like you see, the chaining here is prompts and then the LLM, basically. And then I want to chat with my document. I'm creating um, a very simple function, and then I just call the function and say, uh, what is the main idea of this document, basically. If I once I get this use this function to run the question, this part once I use this particular function to run the question, this is what returns. It invokes the chain here already, and then I can just chat and chat and chat and chat. So and interestingly, again, you can clear your vector DB very, very easy. You can clear your vector DB just in case you want to embed if another kind of document. So you see that if your particular code, one particular code can be reused for different kind of use cases. You don't need to create another solution just because you want to um, you want to use another document for your implementation. All right, so this is just a simple end-to-end description of how to build your own large language model using Ollama. All right, Frank, can you hear me? Hello, Frank, are you there?
Hear me?
Yes. So should we go ahead with the application, or what do you think?
Yeah. So let's go ahead with showing how we can then. So you can test out the application on locally and see whether it works. So when it works, I'll just carry on with the code that you have given me to show how we can deploy this
All right.
to.
Okay. So, oh, you
So
want
give
us
me.
to do this? You want us to do
Sorry,
this now?
no, this is down. Let's go back to the document. So let's see how we can deploy this to AWS. Since I have the code, I'll just share my screen and
All
we'll
right
then
then.
go test it once we have deployed. Okay,
Okay.
thank you so much, Daniel. Um, so let's see how we can then deploy this to AWS. and test out the application that we have seen one part of building it. So we have seen how the whole pipeline works. So typically when a data scientist work, we usually start off with a notebook for experimentation. So Daniel has shown you what the process is to create a RAG system. The other part of it is to show you the part where we can chain all of this within into a script and maybe build a simple front end application to just use the script that we have. But the most important part is showing you the end to end of how RAG works, right? So also the notebook would be shared with the community. The notebook and the entire script for the application will be shared with the community and we're able to play around with it. So now let's see how we can deploy this application to AWS. So I'll share my screen right about now. Okay, so please tell me when you can see my screen. Okay, I guess we can see my screen. So here, so this is all of the code that Daniel and what's the name of our friend again? I think it's Bola worked together to create. And if you can see, what we have done is that we have changed all of these documents, all of the different functions we have changed it into a script for different parts of the document. So we are done with experimentation, and these different parts of the document is different part of the notebooks is what you are seeing as different function within different parts in our script, right? Using LangChain and Ollama. So it's pretty much all of this. So you see where the querying happens, see where embedding happens, and all of that, right? Okay. So now let's see how we can deploy this on AWS. So I would quickly show you. So this is my AWS console, and I want to deploy this to EC2, right? So just so you know, if you want to actually run an LLM locally on your machine, you need to use Ollama, and I will show you how that is done pretty quickly. So if you want to use your document, use any model, what you just need to do is to come here, install Ollama, then you would see the different models that are available within Ollama. So all of these models you see here are open source models. So there's Gamma 3, there's Queen 3 from I think Alibaba, there's DeepSeek from DeepSeek from I almost said the Chinese guys. Yeah, the DeepSeek from DeepSeek. There's Llama from Meta, and there are different models that you could use, including Mixtra. So this is the text embedding model we used here, and this is the LLM that we use there, all within Ollama. Right? So you just need to do is to just come here, click on download for your macOS, or if you download for your Windows, and you can just go ahead to use. Now let's go back to our AWS console. I'm going to be deploying this to AWS, and mind you, I already have this code in a repo. I think I can find that repo here. Give me a second. Yes, I can find that repo here. Okay, so all of this is already pushed to a repo, and I would share with the community. Right. So shout out to Tony. So Tony is also an AI engineer that also helped out with setting out the baseline for what we are doing, and he also has a video online that shows. I think there's a link to the video that shows the process of creating chatting with PDF with Ollama and LangChain, and it said he just created a base for us to modify and get work done faster. So shout out to Tony and open source, right? So okay, so let's see how we can then deploy this code to AWS. So I want to deploy this on an EC2, just like the architecture that we had earlier. So this is the architecture I'm talking about. Right, we want to deploy this entire solution that we have built on an EC2. So I'll go to EC2, and all I need to do is to come here and say I want to launch an instance. Right. So Daniel has tested this code out, and he knows that it runs locally. So if it can run locally, which means that it can run on any server anywhere, right? So I need to run it on an EC2, right? So to run my code on an EC2, I need to select, first of all, I need to say what the name of my server is going to be, right? And let's call it government local RAG. think that name befits the solution. So we are deploying Bola's application, Bola and Daniel's application now. Right. So I need to pick the type of image that will be suitable for the application I want to run. So for those of us that for spinning up your EC2, you need to pick a machine image that you are going to mount on the server to start off as the base of the infrastructure you are going to deploy your code to. Right. So what's an AMI? AMI is what you call Amazon Machine Image. And what it does for you, it's like a template that holds some configuration, including what the operating system is going to be on your server, the type of application, the kind of application server service that is going to be on the server, and again, some of the applications that you would need. So some of these baseline images would contain things like Python already installed and all of that to make sure that you have the base to then install your application on the EC2. So basically, it's like a template. So I don't need to start up a server on my own and start to install and put all of the operating system and all of it on the server before I can use it. So um, there are many machine images that you would use, but because of the peculiarity of the case that we're doing, we are deploying a machine learning solution. Right? So loading an LLM into a server, it needs highly compute intensive a compute intensive server, as we need a server that is highly compute intensive, and we need something that has some applications that need to do with AI already installed, so I don't have to do all of the setup. So fortunately for me, I can just check all different, and I can just install an AMI, mount an AMI that has some deep learning resource along with it. So I can see here, I just want to work with, let me see. So I have to go through all of these different ones and look for the one that, yes. Let me see. Okay. Okay. So I want an Ubuntu server that has baseline for, yes, so I guess this would work. As you can see here, that it has PyTorch already installed within the server, and it also has the NVIDIA GPU already installed within this server. Let me see, is there an Ubuntu image? Not, obviously not. So let's see. Okay, so let me go back just to pick exactly the right image. Let's do this again. Okay. Okay. Yes, so this is what I'm looking for. We want to use an Ubuntu image that has the NVIDIA, so you can see it has Python installed, PyTorch already installed, and is able to use a GPU, right? So for those of us that are wondering what a GPU is, so a GPU is a high compute intensive processing unit that initially that helps us process some information, helps us process information. A lot of stacks that are done, heavy compute stacks are done sequentially very, very well. Machine learning falls into that use case. So many of the systems that use GPUs include like gaming systems, and right now AI is doing a lot with GPUs. So I need to also pick the instance type. So we need an instance type that is highly compute intensive, right? So I may want to pick something from the C class. So let's see, C7, something that is large enough for us to help us run this, right? So let's see some of the flavors that we have available, right? So for because I'm loading a large language model, right, also we need a lot of memory to be able to hold this the LLM that I'm loading into the system. So maybe I'll pick something with an 8 gig RAM. Yes, and then I'll select the instance type. Okay. Also, I need PEM key to be able to connect to the server when I want to, right? To create a secure SSH connection to the server, right? I already created one earlier, so I'll just use it. But if you don't have, you just need to create a new pair. And what it does is to just download to your laptop and you're able to use it to connect to the server. Now, for security, from the architecture we had, something we are just going to deploy it for demo purposes to get all traffic coming from anywhere to be able to reach our server, right? So additionally, if you are doing this for, let's say, for your organization, you may want to make it, you may want to deploy something or architect something that is more security intensive, right? Well, in this case, like I said, you need a lot of storage, so we'll just go ahead to do that. And this is what we are configuring. So we have chosen this machine image, we have chosen this instance type, right? We are also going to create a new security group when we are launching this server, and we'll go ahead to, this is the storage we're assigning to the server. So I'll go ahead to launch this instance. Right. So what it's doing is creating a security group using server. And you can see that our EC2 is currently running. Right. So this EC2 is currently running. So let's see how we can then connect to this server. So I'm going to connect to this server from my laptop. Give me a second. Okay. Let me see. Right. Okay. So yes, so let's connect to this server and we can do some of the operations we need to do directly from this server. So what we can do is, let me see. Okay, let me just go back. So you can see. So this is the root for my system, and my PEM key is in the folder where all of my code sits, right? So I just want to change directory into that, into where my code currently is. It's sitting within a folder. Yeah, it's sitting within a projects folder. Let me see. Yes. And yeah, I named it Ollama PDF rag. Yes. And now I'm in that. So my PEM file is currently here. So what I just need to do is to run this command, and I can go ahead to copy this command to SSH into the server. Yes. And voila, so I'm in. So I'm currently, so within my system now, I'm currently running I'm currently active and into the server that I just started up on AWS. So what I then need to do is to go ahead and bring in the code that I have on the application I've already built here and start up the application within that server. But the first thing I need to do is to, first of all, load and mount Ollama into my server, so I'll be able to load the different LLMs I want to use. So what I would do is to take this command here that helps me download Ollama into my server that is running on AWS. So once I do this, what it's doing now is the new server I just started up, I'm downloading Ollama into the server. So it's very similar to what you are doing when you are installing this into your laptop. So I will install Ollama into my laptop first, then I will now load models that I can use. Right. So it is downloading Ollama, and what I can do, yeah, it's pretty fast. So yes, we have Ollama running within our server or installed within our server. So what I can do is to test it out and see whether Ollama is good. The model I want to use is Llama 3.2, and I will be using the 1B flavor, right? 1 billion parameters. And you can see that if you want to run this within your server, you just need to run this command. All right, you just need to run this command. So let's see. So what it's doing is it's pulling the manifest or the weights, just like Daniel said, of Llama 3B 3.2, 3.2, the 1B flavor, and it is actually running within the server. So I can send a message and say hi. And you can see it is running locally within the server. It says, "How can I help you?" And I will tell it, well, what can I say? What are the 9 planets? And let's see. Okay. And it's making the list. So it's running locally within our server. You can see. Oh, wow. So I just asked it what the 9 planets are, and it's giving me a whole lecture about what those planets are. But let's just do its job. Let's do its magic, and we'll just come back to this repo. So within this repo, you have a set of instructions that we already have to be able to start up this application that we have already built. So we'll be sharing the link to this repo so that we're able to also experiment on our end and make adjustments as regards the application. Right. So I can step out of this for Ollama chats, and yes, I'm back into the server. Right. So what I want to do is to then also pull the embedding model I'm going to use. I already pulled the large language model we are going to use already. So that's fine. So it's also pulling the manifest for that. Right. So now we want to go ahead to clone the repository for all of the code that we have. So mind you, this repository is public. So I'll go ahead to clone the repository, bringing in all the code that we need for the application to work. And I'll go ahead to then go into this application. Yes. So now all of the code that we need is within this application. Yeah. So you can see all the different files that we have within the application, which is similar to all of this that we have here on my Visual Studio Code. Right. So typically, applications usually have three applications that are deployed will have what you call requirements, like Daniel said when he was explaining the different requirements for the code to run. There are different requirements for this code. Example would be LangChain, example would be Streamlit, which helps us build a simple front-end application. Of course, Ollama and ChromaDB and a lot more. So what I will do is I'll go ahead to create a virtual environment within my server and then go ahead to install all the dependencies that we have. So this will take some time, and I will just wait for it to finish up. Right. Okay. So it's a lot of requirements, and I'm doing all of this within my server. Give it a second. While I'm doing that, let me see if I can download a document that's state. Let me see. Okay, let me just see if there's any public document I can get. Let's see reports. Let's see. Okay. Okay. So I know nothing about this document, right? So it's an investment policy on PPP in Lagos State. I will just go ahead to download it to my laptop, and let's see what this is about. So let's see if our installation is so like I said, it's going to take some time for it to install all the dependencies that we are going to need. But yeah, we have a document, and this is what the document has: a lot of information about Lagos State and some policies, which I'm very oblivious about. I know nothing about this document. I just found it, and it's possible I may need to find some information about this document pretty quickly. Um, Interesting. So this is a lot. So first of all, it will be impossible to pass all of this information that I'm scrolling through, right? Pass all of this information that I'm scrolling through currently into an LLM, and what will happen is that the context window is going to it's going to exceed the context window of the LLM, so it will not be able to work. Right? So that's why we need to chunk it. Right? So the first process in your RAG process is actually chunking. So just waiting for the requirements to finish downloading. Okay, so while we're waiting for this, I can't see the chat, but are there any questions on the chat that would require us to answer at this point in time while we're waiting for the installation to finish? Let's see. Next line. Okay. So Oluwabumi says, what are the system requirements to effectively run Ollama? I've worked with I worked with it locally with my M1 Mac before and had very, very poor performance. So Oluwabumi, what models are you loading on with Ollama? Because I'm currently using, yes, obviously there are going to be some issues with loading some quite some large models using your system. I also use an M1 Mac, and for the lower end parameter models is quite it works well in quotes, right? But if you are trying to load something that is, example, a reasoning model that has that's quite large, then it would have some performance issues. I guess Ollama should have some sort of requirements. I guess I've seen that before, but we can check that out. What it is to run, what is required of you for you to be running some of these models in your system. Can Ollama run on the Windows system? Yes, it can, because they also give you ability for you to download Ollama 2 on your Windows application, on your Windows, I said application, on your Windows system too. So let's see. Yes, so it's almost done. Just give it a few seconds and we'll just carry on. Right, let me see. Are there other questions that we have? Okay, private GPT. So let's search for that model. Let's see. So I can't quite find the model here. I was trying to see what the weights look like. But anyways, like I said, it's not one size fits all for running some of these LLMs locally.
Yeah. Hello,
Yes, yes.
can you
So
hear me?
yeah, I can hear you. Then
Man, I've been trying to respond to some of the questions a long time. Yeah. I just knew something was wrong when you were also saying the same thing I had said.
yeah. I didn't hear you when you spoke before. But yeah, there's not one size fits all for all models. The models are quite some of them are smaller, some of them are larger. Even within the same models, you have different flavors depending on um, what the weights look like, right? So we'll just work with at least work within the confines of what you can run. I remember Daniel running something on his laptop and the laptop went ghost on him.
I think that was Llama. That was Llama 2. I think that was like 13 billion parameters or 70 billion. Yes. I had to run back to the 1 billion parameter, which was good for my use case eventually though. So
Okay.
yeah.
Yeah.
So
So
you can do, sorry, Frank.
yeah.
Oluwabumi, you can do a research on these models. The Llama models, you can check what they are good for, so that you be able to balance in terms of accuracy and in terms of speed, right? If there's any model I know I can vouch for that it will not drag, is one you've noticed the one that Frank just ran today was the 3.21 billion parameters. 3.2 is one of the latest Llama models and it's smaller than the older ones. So you should be able to get like a good a good experience with it.
Yeah. Okay. So within our script, what we have a main script that starts up the entire application, and what it does is to just go ahead to start the um main.py script that actually chains everything together, right, with the different helper functions that we have around. Right. So again, we're going to be sharing this repo with the community, so you're able to make modifications if you want to. So to start off this application, all I just need to do is to run the run.py script, and my application should start up. Yeah. So I've started off this application on my EC2 on AWS, and I just need to come here, and where's my, yes, so this is my instance, yes, and it's currently running, right? So what I just need to do is to then use check out the public IP address that is here, and to know what port is currently running on, so I can start the application. That's give it is given here. So what I just need to do is to copy the external URL and see if my application would start. All right, let's see. Aha, there's something I didn't do, so I'm anticipating an error. But let's see if it goes through. Then we'll go back um fix that quickly. Yeah. Give it a second, I guess. Mm, I don't even know whether it's the internet. Let me see. So let's just give it a couple of seconds for it to completely spin up. Okay, so it says the site can't be reached. Right. So which means it's definitely a networking issue or a connection issue. So let's go back to our EC2 and let's see obviously
Yeah,
the,
Frank, can you check the ports?
yeah,
Which ports?
exactly. I need to check the ports that are open. So I'm anticipating that error. So let's see the ports that are currently open. Right. So this is my internet gate. This I said internet gateway. This is the security group. Where is it? That is currently mm, So let's check for our security groups. Instance security. Yes, so this is the security group that is currently attached to our EC2. What you can see is, let's check some of the rules and let's see. So let's edit it. And for now, I can add a new rule and let's say I want all TCP for now. Um, for other use cases, I can make it the security. Like I said, we can modify the security to be a lot strenuous depending on our use case, right? So let's see. Yes. So I've allowed traffic to come to our EC2 now, and our application is actually starting, right? So the two models we have within our this thing is within our system, our local system, right, is on our local EC2 is Llama 3.2, and we also have our embedding model. So what we can do is I'll browse the files. This is the PDF I just got, and I would pass it on, and it will go ahead to start chunking the documents. Right. So it's processing the PDF, and because this process is going to chunk it in real time, so try, basically normally the chunking process is done before we try to chat with the documents, right? So typically, if you are building a RAG application, for example, your customer service application, you would have chunked these documents or dechunked these documents before your customers would want to interact with this RAG application. So let's see, it is now going ahead to chunk the document. So once it is done, we can then chat with the documents to see what the document is about, right? And test the application out. Mind you, this was built with Streamlit, an easy way for us to easily just spin up a simple web application that we can use to interact with our AI applications. So just give it some time to finish the chunking process. So while that is running, are there any other questions on the chat? Let me see. Yeah, thank you, John. Thank you, Ore. Yes, the issue was with the security group. Um, okay. Ore is asking, is there a limit to the number of documents we can upload? Yes, for this, you can upload multiple documents, right? So you can upload multiple documents. So you can see the logs for this server. You can see the request coming in, right? So yes, you can upload multiple documents but our use case, it's still processing. So for our use case, we want to be able to answer questions. So imagine so what it's doing now, it is taking all of the documents and putting it in the same vector DB. So it is doing it within the same vector DB. So imagine if you have multiple documents that are not related and you try to ask a question and it's trying to fetch information from different sources. So for this case, if you want to get the best result, maybe just upload one document or upload multiple documents that are related, right? So let's see if I can ask a question. So let's say, what is this document about? Because I have no idea what this document is about, right? Okay, so let's see. So what it is doing in this case, when you see processing, it is trying to query the vector database that I've already created. But in doing so, the process it is embedding this question that I just have, right, that I just sent in, right? This embedding is now used to do a similarity search to all the different chunks within our database. Then it is then passed to our LLM. LLM uses both the context and the question, and it's then used to produce an answer. So uh, for you to get a faster experience using this application, you may want to use, so if you notice, the application the server will spin up, because we didn't actually spin up a GPU, right? So if you want to get better performance, what you can do is to scale it up, use maybe something with a GPU, and you can start to see better results when you do some of this. But for the case study of just learning and spinning up something quick for us to work with, let's just wait for it to finish all of the different processes that I described and for it to give us an answer. Right. So let me check again if there are any other questions. So can the RAG also work on pictures, videos, or just text documents? So the simple case of naive RAG, right? For the simple case of RAG, it is very easy to just work with um, just text, right? But there are other implementations of RAG that can take into context pictures, videos. Embedding videos are quite not exactly they are quite complex, or it's quite less. Yes, it was difficult to also embed things like videos over time. But yes, some other advanced implementation of RAG can take context from pictures and the rest. But for the naive RAG case, it's just the text that we're working with. So this is taking some time. Just give it a second. So maybe we could have used a much smaller document. Just give it a second. It's able to respond. Yeah, Daniel, are you saying something?
Yeah, can you hear me?
Yeah, I can hear you. I can hear you, Daniel. Okay. Right, so it has responded. So you say, what is this document about? And it says this document appears to be investment policy document for infrastructure development, specifically focusing on procurement practices for public-private partnerships. It outlines the policy framework and guidelines for procurement processes in Nigeria. So I didn't have to read this document for me to be able to find out information about this policy document. For Nigeria and in Lagos State. So you can see how the end-to-end system for RAG works and how we can build our own RAG system. So thank you so much for listening in. We'll be sharing the resources we used during this demo and the class with the community later on. So thank you very much. Christiana, are you there?
Hello, Frank, can you hear me?
Yeah, I can hear you clearly.
Oh, yeah, sorry. I was saying before that my PC went off, so I had to switch to my other device.
Okay.
Yeah, so I think I was hearing a question about if you want to rag an image or rag a video.
Yeah.
Uh, it depends on what you really want to achieve. Why do you want to rag a video? Is it that you want to use it to search for the video, or is it that you want to use to search for the images? So there are different ways you can actually go about that, but maybe RAG in itself might not be the best implementation for that. You can then maybe use uh, there are different ways you can tag. You can like give that image a tag that can be pulled. So like a tag, yeah,
Metadata.
a tag is what, yes, a meta tag exactly that can be pulled, and then you can now be able to view that image maybe from the front end or whatever you are using to display the image. You can then use it to interpret the meta tag. So it depends on how. So you see, that's an easier implementation. Yeah. So other people might say use a model that has a very large context window, like Gemini models that are also multimodal. So that's another use case. So yeah, just I just have to put it there for the person that is asking, just in case he's thinking of implementing something like this.
All right, thank you, Daniel. Christiana.
All right. Thank you. Thank you very much, Frank and Daniel. It's been an amazing and an interesting journey and topic. And I know it's been a lot for a lot of us. For me, especially because this is new, and thankfully this session is recorded, so we can always go back to it to always rewatch, because I saw some people asking questions about this. And I don't know if we have any other person that wants to join, ask a question rather. This last question, I don't know if it was answered. Can Iraq also work on pictures, videos, or just
Yes, yes, we have answered the question.
okay? Very perfect. I have just one question. In terms of security, I don't know, is there like any kind of authentication before you can integrate Ollama using the API on the chatbot?
Okay, so what we built today is what you call a level one for in terms of in case RAG security and all of that. So the application we built today is not typically what you have. You want to have very secure systems. So the security bit in this case is because is where we speak to security as regards what we built today is how the large language model is running. So typically, if you are using an API for a large language model, example, if you are using maybe through Bedrock, you are using Claude's Anthropic model. What happens is that you are making an API call to Trump's Anthropic model, and what it does is the data is processed on their server and not yours. Right? So you are moving your data. So where the solution will come in with localized RAG is the RAG LLM is sitting within your server. It's sitting within your VPC and within your subnet. So nothing goes out of the your EC2. Right. So that's where we have a lot of security. So this use case is good for government process. If example, if you are building something for the Nigerian government, some of the data is internal documents. So you want everything to be processed within one server, and you're not making API calls to do either retrieval or to do generation or to do embedding. So everything is done within one server, right? And you can abstract other solutions on top of it. So if you build your application on an EC2, right, before you make API calls, you can also add in authentication. Typically, what you typically do to any of your applications, you can just add those toppings on top of the base pizza that we have. Right, so that would answer your question.
All right. Thank you very much. That's very profound. Can we give Daniel and Felix a virtual round of applause in the comment section, like those fire emojis? I know if they are clapping, we might not be able to hear, but we can just give them thumbs up and just clap for them. Thank you very much again, Felix. That was a great deep dive. And I think we're going to go right into the trivia games now. Let's be sure that everyone has been paying attention and they can get to answer our questions that we have today. And like I said earlier on, we have some goodies, and you get to know the goodies. That is for those that are able to answer our questions correctly and are the fastest. So we're going to wait for the link to come up, the haha slides. Okay, I hope everyone is set. The link has been dropped. It's showing on the screen and in the comment section. Please click on it. While we wait for everyone to join. I would have loved to join on and answer everything and win, but you guys think I was the one that said the question. That's why I'm winning. So I'm not going to do that. Thank you, David. David has joined. Who else? Ah, Chiamaka is clapping for Felix and Daniel. Thank you, Chiamaka. We're about to start now. Okay, I guess we can start it now. What is the primary advantage of using a vector database in a retrieval augmented generation system? Let's see who's going to answer this. Wow, 4 people got this right. It allows efficient similarity searches. Amazing. That was very easy. Wow, Ola is the fastest here. And Tundai. The second question is here. What is the key advantage of running RAG models locally on EC2 instances? Let's see who's going to get this now. Oh, 7 people got this right for faster data retrieval due to proximity to the source. Wow, Olajide topped this. They have relegated the other person. This is very interesting. When selecting EC2 instances for running AI models, which of the following is most critical for optimizing compute resources? Let's see who got this right. 5 people got this right. Selecting compute optimized instances. Whoa, that took a huge turn around. I didn't see this coming. John Toby. Wow. What is the primary function of retrieval step in a RAG model? David, you are doing the same quiz. It's the same thing. You're probably not as fast as the other people getting it. 7 people got this right. John Toby again. John Toby just came from nowhere and overthrew everyone. What does the generation step in the RAG model do? Wow. Ejibode Ibrahim, wow. He has overthrown John Toby. That was very, very close. Congratulations, Ejibode Ibrahim. He had 313 points and is the leader of this leaderboard. So, Ejibode, if you can hear me, kindly take a screenshot of the page and email it to this email address that you can see across your screen, awscloudsecwestafrica@gmail.com. Send the screenshot together with your full name to this email address, and congratulations again. That was very interesting. I mean, you agree with me that it has been an interesting time since the beginning of this session, and our time is overspent already because today was quite intense. And thank you everyone for joining today's session. Next week is another time. Meet us here, same time, same venue. And if you do not have the link, I think it has been shared in the comment section for you to register, join the community, and so that you can have subsequent notifications about other study series that we're going to have. And also feel free to connect with everyone. We're not just here to learn, we're also here to connect, have fun, and basically just level up in different areas of our careers. Fife, no second prize. Oh, that's so sorry. It's just for the top person at the leaderboard. The top person on the leaderboard, yes. So thank you everyone for joining. Don't forget to join next week. Thank you very much and have an amazing evening. Good night, everyone.